Guys, let's do example number 9 in chapter 8. And here we're given data and we're asked to find the best possible model. But you're asked to use two criteria. The first criteria, which is the more traditional one, is to only include variables with a p-value less than 0.05, meaning that there is a small chance this happened just by luck. That's really the interpretation of the p-value, which I have to say I go into a lot of detail on my videos, but the previous videos, not the WebEx videos, the YouTube videos. Anyway, let's look at the data. Let's bring it into StatCrunch. And we can go to stat, regression, multiple linear, because we have many variables. We're trying to predict somebody's credit score based on these three numeric variables. Hit compute, and it turns out that two of the variables are really not that relevant. P-value much bigger than 0.05, slightly bigger, but we're going to be technical about it, it's bigger than 0.05. And therefore, we're going to redo the calculation involving only revolving utilization. So I'm going to erase this, go back to stat, regression, simple linear, because we only have one variable. The x variable is revolving utilization, the y variable is credit score, compute, and we have the following numbers: 757.92, which the student has been nice enough to type in, minus 220.73 is the slope, or the coefficient in front of utilization. And I believe we're going to need the r squared. Oh, there it is. The r squared is 0.634. I'm going to write it down because I know we need it for 0.634. We'll come back to that in a second. Okay, this is the slope, pretty close. The dots are pretty close to the straight line. Okay, now let's move on. We're going to need this data. Let's put it aside. Don't need this anymore. Let's check. Oh, we're not finished yet. Now they want you to do the best model using the t-statistic. Here, the criterion, which is really very rare, is if it's bigger than 1, we keep it. If it's less than 1, we get rid of it. So let's look at that. To show you the different ways to decide which variables are relevant. There are a million different ways. So let's go back to the StatCrunch, which we already have. Go back to regression, stat, multiple linear again, predicting credit score from these three variables. And we see that the t-statistic, which is really the number that's translated to a p-value, are all bigger than, especially in absolute value, bigger than 1. I mean, minus 1.4 is technically less than 1, but we're going to ignore the minus sign and just see how big it is in terms of magnitude. So all three variables are going to be included, and therefore, and the r squared, which we're going to need this time, is 0.664. 0.664. We're going to copy these coefficients into little boxes here. Again, we're using all three variables, so the answer is part F. The year coefficient should be readily available if I find it. It's, no, wrong problem. A year should be minus 2.098. That makes no sense. The other variable is 0.000156. C. And the percent utilization is, find it again, 246.22. The reason why I said this doesn't make any sense, this is implying that the more years you have credit history, the lower your credit score. Well, maybe more bad things keep happening over the years, but it doesn't really make sense. And we did it. Now comes a problem. The first R squared model I said is 0.634, which is less than the second model, which is 0.6664. So if you just remember, R squared measures how close the dots are to the straight line, and the higher the better. The highest it could be is 100%, or 1.00. So therefore, the second model, which has 3 variables, seems to be better. On the other hand, if you apply the principle of parsimony, which if you read in the textbook means that we try to pick the simplest model, if we can. In this case, 2 models are almost the same, except this one only has 1 variable, because the R squared are close, differ by less than 0.05, 664, 664, I mean, much less than 0.05. So the better model using the principle of parsimony is the first model. Now here's the problem. Check answer, and they're going to mark us wrong. And check answer again, mark us wrong. And check answer, final check, and these are the answers. So 6.3, we're right about the number, right about the 6.65, that's just irrelevant. But the main thing is does not apply is what they want us to write down, and I wrote down apply. So I wrote to the publisher, because I find a lot of mistakes in this chapter on these answers. So I would recommend you wait a few days till the publisher changes it, because the right answer does apply. Or if you want to be cynical about it, just type in does not apply right now, and you'll get it marked right if you get all the other numbers right. Okay, that's it for that example. Sharing and meeting.